This time, I'm going to talk about building trinomial tree for CIR model in Python. About 2 months ago, I made a video talking about building trinomial tree for Black-Karasinski model in Python. One of my video viewers asked me how to do it for the CIR model. In this video, I'm going to answer this question. Now, let's take a look at CIR model first. The CIR model is a type of one-factor short rate model where the short rate follows a square root diffusion process. This is the formula for the CIR model. You can see the RT is the short-term interest rate at time t, and kappa is the speed of mean reversion, and the theta is the long-term mean level, and the sigma is the volatility, and this WT is the Wiener process, and usually we use standard Brownian motion. CIR model has the following features. First, the interest rate reverts to the long-term mean theta. And because we have a square root RT here, the square root term ensures that the interest rate cannot become negative. And the CIR model allows for closed form solutions for zero coupon bond and other derivatives. Also, CIR model captures the empirical observed behavior of interest rates. Now, let's take a look at Black-Karasinski model. I talked about Black-Karasinski model in my previous video already. Let's review it again. The Black-Karasinski model is a log normal interest rate model, which means it models the logarithm of the interest rate as the Ornstein-Uhlenbeck process. This is the formula for the Black-Karasinski model. The RT is the same with the CIR model is a short-term interest rate at time t, and the theta t is a time-dependent mean reversion level. Beta is the speed of mean reversion, and the sigma, similarly to the CIR model, is the volatility, and WT is the Wiener process. Black-Karasinski model has the following features. The model incorporates mean reversion, where the interest rate reverts to a long-term average over time. So this is the same with the CIR model. And Black-Karasinski model ensures the interest rate remains positive. And the model can fit various term structures due to the time-dependent parameter theta t. Now, let's compare CIR model against Black-Karasinski model. And first, the Black-Karasinski model is a log normal model, but the CIR model is a square root diffusion model. And the equation for the Black-Karasinski model is here, as I showed before, and the CIR model, the formula is this one. Both models have this mean reversion feature. And for the interest rate, for the Black-Karasinski model, it will be always positive. And for the CIR model, it will be non-negative. That means it can be zero. For the distribution, Black-Karasinski model follows log-normal distribution of interest rates, but the CIR model follows non-central chi-squared distribution. And the Black-Karasinski model is more complex due to log-normal dynamics. And the CIR model has these closed form solutions for many derivatives. For the flexibility, Black-Karasinski model is high because it has this time-dependent mean reversion level. But in CIR model, it has this fixed mean reversion level. Usually, we use Black-Karasinski model for interest rate derivatives pricing, and we use CIR model for fixed income securities interest rate derivatives. When we use CIR model, we need to remember one condition. For the CIR process to remain strictly positive, the failure condition must be satisfied. So 2 times kappa times theta must be no less than the square of the sigma. As I mentioned before, kappa is the speed of mean reversion, theta is the long-term mean level, and the sigma is the volatility. If the failure condition is met, the interest rate process will not hit zero. Otherwise, it might touch zero. In my previous video, I talked about how to build a trinomial tree in general, in detail already, so I will not repeat it again. If you want to know how to build a trinomial tree in general, please watch my previous video. Now, let's go to Python to see how I built this trinomial tree for CIR model. This is a Python program I developed in order to build trinomial tree for CIR model. For most of the part of this program is quite similar with my previous video when I built the trinomial tree for the Black-Karasinski model. The main difference is this: we use this CIR formula to replace the Black-Karasinski model formula. If you want to know how it works, I explained in detail in my previous video. You are welcome to watch that video first. First, if we remove this randomness, we put this winner equal to 0, and then you can see the interest rate will start from 0.05, and this long-term mean is 0.06, and I only show 5 steps for now. If we run the model, you can see it starts from 0.05, and then it will gradually go to 0.06, the long-term mean. And this CIR model tree looks like this. I plotted this trinomial tree for CIR model here. You can see for the different step, for every node, I wrote the interest rate here. You can check the number. And now, if we add some randomness, we run the model again. you can see it starts from 0.05. It goes like this. That's too much. It tries to come back, and then it's trying to get the long-term mean 0.06. Now let's change it to 50 steps. We run the model. It will take some time. You can see in this trinomial tree, because there are too many nodes in the tree, I will not display the interest rate number here. It's hard to read. And if we check the average interest rate, you can see it starts from 0.05 and goes here and goes here, and basically it will bounce around this 0.06, this long-term mean. I will upload this Python code to my GitHub so you can download it and change the parameter and run it to see by yourself. This is how I can build trinomial tree for CIR model in Python. Please provide your comments and subscribe to my YouTube channel. Thank you.